Trigonometry, an exercise on trigonometric identities. Remember, we have sine squared theta plus cos squared theta equals 1 and sine theta over cos theta equals tan theta. Also, we have that if theta naught is the principal value of the inverse sine, then the general solution theta is equal to theta naught plus n times 360 or 180 minus theta naught plus n times 360. If theta naught is the principal value of the inverse cosine, then the general solution theta is plus or minus theta naught plus n times 360. And if theta naught is equal to the principal value of the inverse tangent, then theta equals theta naught plus n times 180. Now the following is an exercise. Pause the video at this point and have a go at the questions yourself. When you've tried them, restart the video and I'll go through the solutions. Okay, now in each question there are two parts. First, write each of the following in terms of either just sin x, just cos x, or just tan x. And in the second part, solve the equation for values of x between 0 and 360 degrees. Well, in question 1, we're given 2 cos squared x equals sin x plus 1. So to solve this, we'll write it down. Now we know sin squared theta plus cos squared theta equals 1, and so cos squared theta equals 1 minus sin squared theta. Now we can replace cos squared x in the equation with 1 minus sin squared x in the equation. And then we can expand the brackets. So this gives us 2 minus 2 sin squared x equals sin x plus 1. And we can subtract sin x and 1 from both sides to get 1 minus 2 sin squared x minus sin x equals 0. And if we change the sign all the way through, we get 2 sin squared x plus sin x minus 1 equals 0. Now in the second part we're asked to solve that equation. Well, we notice it's a quadratic equation in sine of x. And so we can factorise it as sin x plus 1 into 2 sin x minus 1 equals 0. Now if two things multiply to make 0, one of them must be 0, so sin x is equal to minus 1 or 2 sin x is equal to 1, which means sin x is minus 1 or sin x equals a half. If we take the inverse sine of each, we find that the principal values are minus 90 and 30. Now minus 90 is not in the range, but we have other values. X is equal to 180 take away minus 90, which is 180 plus 90 or 270 degrees. Or if x is 30, we can have 180 minus 30, which is 150 degrees. All other values after that are too large, and so we have three possible solutions. X is equal to 270 degrees, or x is equal to 30 degrees, or x is equal to 150 degrees. Now we can see this if we draw a graph. If we draw a horizontal line going across from point 5 on the y-axis, that crosses the curve at 2 points, 30 degrees and 150 degrees. If we draw a line at minus 1 going horizontally across, we find it touches the curve at only 1 point, 270 degrees, and so we get the same solutions as before. In question 2, we're given 3 cos squared x plus 2 sin x equals 2. Now we know cos squared theta is 1 minus sin squared theta, so we can replace cos squared x with 1 minus sin squared x. Now we can then expand the brackets, and that gives us 3 minus 3 sin squared x plus 2 sin x equals 2. And if we subtract 2 from both sides, we have 1 minus 3 sin squared x plus 2 sin x equals 0. And that can be written as 3 sine squared x minus 2 sine x minus 1 equals 0, and that's our answer to the first part. Now in part 2, we want to solve that equation. Now it's a quadratic in sine x, so it can factorise as 3 sine x plus 1 into sine x minus 1 equals 0. Now if two things multiply to make 0, one of them must be 0, and so 3 sine x equals minus 1, or sine x equals 1. So sine x is equal to minus a third, or it's equal to 1. If we take the inverse sine of each, we find that the principal values are minus 19.5 degrees and 90 degrees. Now we can't have a negative angle, and so we need to look at the other cases. X could equal 180 take away minus 19.5 degrees, which would be 199.5 degrees. Or it could be 360 degrees plus minus 19.5 degrees, which is 340.5 degrees. And if x is 90, that is the only case it can take. So we have three solutions. X is 199.5 degrees, or it's 340.5 degrees, or x is equal to 90. Now we can see this on a graph. If we draw a line horizontally across from minus a third on the y-axis, we see it crosses the line at 2 points, 199.5 degrees and 340.5 degrees. If we draw a line across at y equals 1, we get it touches the curve at 1 point, that's at 90 degrees. And so we can confirm our original answers. In question 3, we're given that 6 sine squared x plus 5 cos x equals 7. Now we know sine squared x equals 1 minus cos squared x, so we can substitute sine squared x as 1 minus cos squared x. Now we can then expand the brackets, and this gives 6 minus 6 cos squared x plus 5 cos x equals 7. And we can subtract 7 from both sides. This gives us minus 1 minus 6 cos squared x plus 5 cos x equals 0. And this can be rearranged as 6 cos squared x minus 5 cos x plus 1 equals 0. And that's our answer to the first part. Now for the second part, we've got to solve that equation. We have 6 cos squared x minus 5 cos x plus 1 equals 0, and that's a quadratic equation in cos x. So we can factorise, and that gives 2 cos x minus 1 into 3 cos x minus 1 equals 0. Now if two things multiply to make 0, one of them must be 0. So 2 cos x equals 1, or 3 cos x equals 1, which means cos x is equal to a half, or cos x is equal to a third. Now, if we take the inverse cosine of each of those, we get principal values of x equals 60 or x equals 70.5 degrees. Now, if we want the general solution, x is 60 or x is equal to 360 minus 60, which is 300 degrees. If x is 70.5, x can also equal 360 minus 70.5, which equals 289.5 degrees. So we have four solutions: x is equal to 60, or 300, or 70.5, or 289.5 degrees. Now we can see this if we draw a cosine graph. If we draw a line across where y is equal to 0.5, or a half, we see it crosses the curve at 2 points, at 60 degrees and at 300 degrees. If we draw a line across where y is equal to a third, we see again it crosses the curve at 2 points, 70.5 degrees and 289.5 degrees. These are the same answers that we had before. In question 4, we're given the equation 6 sine squared x plus cos x equals 5. Now we know sine squared x is equal to 1 minus cos squared x, so we can substitute sine squared x as 1 minus cos squared x. Now we can expand the brackets, and this gives us 6 minus 6 cos squared x plus cos x equals 5, and if we subtract 5 from both sides, we have 1 minus 6 cos squared x plus cos x equals 0. Well, that can be written as 6 cos squared x minus cos x minus 1 equals 0, and that's our answer to the first part. Now in the second part we want to solve that equation. It is a quadratic in cos x, and so it factorises as 2 cos x minus 1 into 3 cos x plus 1 equals 0. Now, if two things multiply to make 0, one of them is 0, so 2 cos x equals 1, or 3 cos x equals minus 1, which means cos x is equal to a half, or minus a third. Now, if we take the inverse cosine in both cases, we get principal values of 60 degrees and 109.5 degrees. Well, if x is 60, then x can also be 360 minus 60, which is 300 degrees. And if x is equal to 109.5 degrees, then x can also equal 360 minus 109.5 degrees, which is 250.5 degrees. So we have four answers. X is equal to 60 degrees, or 300 degrees, or 109.5 degrees, or 250.5 degrees. Now we can see this in a graph. If we draw a line on the cosine graph horizontally from y equals 0.5, we see it crosses the curve at 2 points, 60 degrees and 300 degrees. If we draw the line across at y equals minus a third, we see it crosses the curve at 2 points, 109.5 degrees and 250.5 degrees. In question 5, we're given the equation cos squared x equals sin x minus 1, and we know cos squared x is 1 minus sin squared x. So we can make the substitution cos squared x becomes 1 minus sin squared x. Now, if we subtract sin x and add 1 to both sides, we end up with 2 minus sin squared x minus sin x equals 0, which can be rearranged as sin squared x plus sin x minus 2 equals 0, and that's our answer to the first part. Now in the second part we're asked to solve the equation sin squared x plus sin x minus 2 equals 0, and we can factorise it as sin x plus 2 into sin x minus 1 is 0, which means sin x is minus 2 or sin x is equal to 1. Well, if we take the inverse sine of both, there is no inverse sine of minus 2, so that doesn't give us any solutions, and the inverse sine of x is 1, only has one solution, x equals 90. And so that is our sole solution. Now we can see that on a graph. If we draw the sine graph, and we draw a line across where y is 1, it only touches the curve at 1 point, and that's when the angle is 90 degrees. If we draw a graph across at minus 2, we see that it never crosses the curve, so there is only the single solution, x equals 90 degrees. Now in 6 part 1 we have 5 sin x equals 4 cos x, and we can divide both sides by 5 cos x. Now on the left hand side the 5's cancel, and on the right hand side the cosines cancel. And this leaves us with sin x over cos x is 4 over 5, but we can replace sin x over cos x with tan x. And so we have tan x is equal to 0.8. And that's the answer to the first part. Now in the second part we want to find the values of that between 0 and 360 degrees. So we start with tan x equals 0.8 and we take the inverse tangent. And that gives us a principal value for x of 38.7 degrees. Now, the general solution is 38.7 degrees plus n times 180. So we can also have n is equal to 1, which means x can take the values 38.7 degrees or 218.7 degrees. Now we can see this on a tangent graph. If we draw a line across where y is equal to 0.8, we find it crosses the curve twice, once at 38.7 degrees and once at 218.7 degrees, thus confirming our original answers. Now, in question 7, we're given 3 cos x plus 2 sin x is equal to 0. Now we can write that as 2 sin x equals minus 3 cos x. And if we divide both sides by 2 cos x and cancel, we get sin x over cos x is minus 3 over 2. So tangent of x is equal to minus 1.5. And that's our solution to the first part. Now in the second part we want to solve that equation and get the values between 0 and 360. We can use a calculator to evaluate the inverse tangent of minus 1.5. Well, this gives us the principal value. We find it's minus 56.3 degrees. But we can add 180 degrees onto that as many times as we like. So we can have x is equal to minus 56.3 degrees plus 180, or minus 56.3 degrees plus 360 degrees. And they give us 123.7 degrees or 303.7 degrees. Now, we can demonstrate this in a graph. If we draw the tangent graph and then draw a line across at y equals minus 1.5, we see it crosses the curve at 2 points, 123.7 degrees and 303.7 degrees. Now in question 8 we're given 3 cos x tan x equals 1 minus 4 sine squared x. Now we can substitute tan x is equal to sine x over cosine x. And then we can cancel the cosines. Now that leaves us with 3 sine x equals 1 minus 4 sine squared x, which can be rearranged to give 4 sine squared x plus 3 sine x minus 1 equals 0. Now that's a quadratic equation in sine x, and so we can factorise it as 4 sine x minus 1 into sine x plus 1 equals 0. So 4 sine x is equal to 1 or sine x is equal to minus 1, which means sine x is equal to a quarter or sine x is equal to minus 1. Now, if we take the inverse sine of both of those, we get the principal values are 14.5 degrees or 270 degrees. Well, if we consider the general solution, we can have 14.5 degrees or 180 minus 14.5 degrees, which is 165.5 degrees, or we've got x is equal to 270 degrees. So there are 3 possible solutions: 14.5 degrees, 165.5 degrees, or 270 degrees. Now we can see this by drawing a sine graph. If we draw a line across at y is a quarter, we find it crosses the line at 2 points at 14.5 degrees and 165.5 degrees. If we draw a line across at y equals minus 1, we find it touches the curve at 1 point only, and that is when x is 270 degrees. So we have the same 3 answers again.